Hey everybody, it's OC. I'm back here with some more Java tips for you guys. I haven't done one in a while, so I figured this would be a good time to get back in, seeing as I haven't done one in a while and I need to get back on the Java train here. I've been dabbling around in too much other stuff to actually be ready to teach stuff again. So I'm going to start my back in action with actually a pretty tough topic. Interfaces. Things that at first interfaces are like, duh, what the heck do you need an interface for? But these are very powerful ideas that we use specifically in Java. Other languages use them too. But Java uses interfaces as a way to get around some of its limitations of multiple inheritance, if you know what that is. So we're going to take a look at this a little bit and show you how you can use it, how it's beneficial, and what's the kind of OO idea. What's this object stuff about it? Because without understanding that, then why would we even have it? Because it's just straight useless then. Okay? So let's take a look at something we might be interested in. Okay? So let's look at some stuff today. Like for instance, let's look at like a Mustang. Yeah. Nice red Mustang. Doesn't that look good? That looks like a nice Mustang, don't it? Yeah. See, there's a nice red Mustang. Yeah, don't you wish you could own that? Or maybe you would want to, and you could have out in one of these. You could also have maybe like a GTI. Maybe you'd like the Volkswagen kind. Or maybe you're a Mini Cooper person. You want a nice Mini Cooper. Yeah, look at that. Blue one. Ooh, nice. Ooh, another kind of purple. Whatever. I don't know colors very well. Anyway, and maybe you have a nice kitty at home. Yeah, it's a nice... Not that kitty. Let's try a different kitty. How about we just go with a cat? And you have a cute, adorable little kitty at your house. You're just like, oh my god, that's a cute kitty. Oh my god, that's a cute kitty. Or maybe your kitty's something even cuter. Maybe it's like a raptor. That's definitely not a raptor. That's a truck that's a raptor. But how about a raptor dino? And see how that works out. There we go, a nice raptor. Who doesn't want a cute raptor at their house? So anyway, we start with the idea of some objects, okay? And the idea is, like, all these objects may seem to have nothing in common, but they do in a way. One way that these guys might all have things in common is all the colors they had. Like there was a cute little kitty cat. We had a really cute little kitty cats of all the different shapes and colors. Aren't they so cute? Okay. Boy, he does not look happy. Anyway, and if I just look at a Mustang again, I mean, look at all the different colors of Mustangs there are. So if we want to think about object-oriented and we think about problem solving, some objects we want to work with may not link up in the direct correlative fashion, but maybe they have to link up in some way that we need to make sure that we can guarantee they have some ability that they all have. Okay, so for instance, an ability all these objects have is a color, and I should be able to get their color. So let's take a look at that in an OO idea in NetBeans and take a look at it. Okay, so I've already created some of this project for us here. All right, what I've created is I've created first a driver program. All right, and this driver makes reference to these cars. It makes cars. We'll see how cars are made. Makes kitties. Currently declares shirts. Doesn't do anything with those shirts yet. But we have some driver that's kind of pre-built a little bit. So let's look at the car first, because it seems like car is something that's already taken care of. So we have this public class car and then implements. Colorable. What is that? Well, let's just go ahead and take a look at it. Here's my colorable.java. Colorable is essentially an interface. An interface is just a way to say that if you implement this interface, if you were going to implement this interface, if you say you want to implement it, you will have the methods that are described in this interface. In this case, I just have one. You must have public string get color, bam, end of story. You got to have it. Okay? You say you're going to implement my colorable interface, you must have it. Because an interface says, hey, I can be interfaced using the colorable interface, which would tell anybody else that, hey, look at that. You're going to have the getColor method. It will return a string. It will be public. It will take no parameters. And that's it. If you have to implement colorable, if you're going to do it, you guarantee everybody else that you will have that method. You guarantee it. You're like, but wait, you don't have a body here. Oh, see, you put a semicolon at the end of that. That's okay. Usually you're used to putting like bodies here, but we don't put bodies in interfaces because we don't want to tell you how that method's going to work. I just want you to guarantee you're going to have it. How it works, that's up to you. I just want to guarantee that you're going to have that thing, because without it, then I can't count on your object working as a colorable type object. If I just want to see how many colors do I use in all the stuff I own, this might be something I would be interested in. We'll look at using it in a more concrete fashion in another video right after this. Okay. So for now, I had this interface, colorable, has public string get color, semicolon. That's an abstract method. Abstract method. Which means this is a method that has no implementation. It cannot work. It cannot do anything. It doesn't work, or it's not going to make you cookies. It's not going to make Mustangs for you. It's not going to give you any kind of color. It's abstract. Like, oh, I'm going to have a get color method. Ooh. Okay. But that's all you know about it right now. Okay. So let's look at car again. So if you say you're going to implement an interface, you put it in the class declaration. You say public class car, like we always said for any object. Public class, name of your object. And then we're going to say implements colorable. We are now going to assert. Watch that word assert. But we're going to say, contractually speaking, that I'm going to have that method inside of this class. So we better see that method in here, or this thing better generate an error. Okay. So let's look for that method because we should see it. Constructor, not helpful. Fill up, okay, whatever that does. Drive, okay. Get make, that's great. Get model. Get color! Hey, look! Public string get color. Public string get color. No parameters there, and not a parameter here either. The only difference is, since this is an actual object that we can create, I have to define how this method works. Okay, so I not only have the method, but I also concretely define it, because this is going to be an object we're going to make. Okay, and if we're going to make it, then it's got to have something it can do. Now, all I want mine to do here is return color. It's pretty simple. I mean, because we're going to have the car. The car takes in its color. Okay, as when it's constructed, and so, well, if I just want to get its color, just get its color. I mean, that's about it. Okay, I mean, I could just do anything I want. People are like, oh, that's all you want to do. I could have system.out.println donkeys are lollerkins. Yay, donkeys are lollerkins, and it returns color. Yeah, it doesn't matter, man. Your get color can do whatever it wants. The only thing that we got to know is it's got to return a string. What's the string it returns? I would assume the color. I mean, let's be honest here. Yes, you can return the 42, which would be the answer. However, we don't really expect that. We expect to get color of some sort. But I mean, your get color could work however you want. If you want to randomly just generate a color and put it back, go for it. I mean, it doesn't make any sense because like a car doesn't. I don't go look at my car and it randomly changes color. So the idea is a property that it has. So I'm just going to return the color on this. Okay, and then it doesn't mean I can't have other methods. So you see all these other methods. I have a fill up method. It fills up the car. I have a drive method. I have a get make, get model. I have a constructor. It has instance variables. They should be private. Gee, sure, see, what are you doing here? Making non-private. Gosh darn it. Anyway, violating encapsulation. What are you doing? Anyway, so you can still have this object do whatever you want, but by implementing colorable, I guarantee I'll have that get color method exactly as described as the interface. Okay. By the way, you can also implement multiple interfaces. So if you want to implement colorable and drivable and comparable and donkeys and lollers, you can implement all those. You can have that. You can implement as many as you want. You're going to guarantee that whatever methods those things say you're going to have, you will have. Okay. Because that's the contract you enter into when you implement an interface. Okay. So by that idea, Kitty should implement colorable as well. And what method should we see again? What's that method that colorables all have? This is implementing colorable. So let's got that method right there. Gosh, it's like it should have that method like Go get color. Yeah, and not any modification. It is exactly the same header you saw in the interface. Hey, look, it's the exact same one you saw in car. This one returns color too. Okay. Now again, maybe this is a cat that randomly returns a random color whenever it wants because it's one of those cats that magically changes colors. I don't know, whatever it does, and you make your kitty do whatever the heck you want it to. But you guarantee that you're going to have that method. You guarantee it'll take no parameters. You guarantee it'll be public. And you'll guarantee that it returns a string, we would assume, that represents the color. However, technically that's up to you. So that's and again, this guy has its own things. It constructs itself with a color, a name, what it says. It has a speak method, has a birthday method, has a get name method. So it can do all. Oh, look at that! Oh, sizzle, violating encapsulation again. What are you doing? It's encapsulation. That's a little JK. Anyway, so these are things that you can do. So the object can still do whatever you want it to do, but now it's a colorable type. And now I know as a programmer that if that object implements that, and I want to get colors of these things, I can get their colors. That's the contract you enter in upon. Okay, so I said we're going to reference a shirt here, so let's make some shirts. Okay, so first statement, what do we got to have with our public class statement if we want to implement that interface? What's that statement? I want to implement that interface. I want to implement the implement. Yeah, look, it's a reserved word. Yeah. I want to implement the colorable interface. All right, colorable. OC. You got to follow the same capitalization you always had, okay? Gosh darn it, you silly kids. Now, NetBeans will automatically give you an error. You can go ahead and click on it and do it if you want, things like that. It's just going to tell you, if you're implementing colorable, then you need to have the public void get color method. And it needs to be implemented. Right now, I'll just return that just to make it all happy and things like that. Oh, no. Oh, no. Oh, no, it's not return. Oh, my gosh. Oh, that's right. I don't return void. I return a string. So remember, this has got to be exactly as the interface. Now it's fine. Okay. So if you implement colorable, you got to have exactly that method. Now, that could be the only method you have, by the way. I mean, literally, I could leave this alone. It's going to do it. Not going to make any sense. Not going to represent a shirt. But it is implemented colorable, and it returns, an empty string. That's so very useful. So let's make some instance variables. We'll just make it a size, private, we'll call it a string for like small, medium, large. Private string size, color, and, I don't know. Let's also make it have a type. Polo, short sleeve, something like that. Okay, so we still got to do our constructor, so public shirt, and we should allow the person calling this object to supply that stuff. So a size, string a color, a color, and string a type. Okay, and we'll go ahead and set our values appropriately, and set the color to the a color parameter, and set the type to the a type parameter. All right, sounds like a plan. And then what method should this have? I don't know, public string. Maybe I can look at the tag every now and then and look at its size in case I forgot. So I'll return the size. Maybe if I'm organizing things, maybe I want a public string get type. I'm going to order by type. Okay, and I'll return the type. And that's pretty much it. Maybe you modify the shirt. Maybe we'll make it a public void change type. We'll change it from like a polo to a short shirt sleeve, or a long sleeve to a short sleeve. Nice, good thinking. Why not? Right? Why not? String new type. And so the type now becomes the new type. Look at that. That'd be kind of handy dandy. Anyway, so there's my shirt. Implements colorable, has a get color, and everything else is like we've done in the past. So there's nothing new here except for you're guaranteeing that it's going to have the get color method exactly as described in the interface. Like, oh, this is all great. Okay, I'll get predictability. Oh, that's so great. You know, why can't we just agree upon it? Well, number one, if we verbally or even write down agree upon things, there are so many times when people go on their merry way and say, oh, I'm going to have that method. Of course I would. Why wouldn't I? And they just decide to, you know what, you're like, well, maybe I want to provide an int here, that's like X. And they just do that not thinking about it. And then when the group gets back together to pull their programs together, it's like, whoa, why, Bobby, why doesn't your work? And Jennifer, oh my gosh, why does your color work so much better, but it doesn't interface with our stuff? That's one of the things about an interface. It just definitely establishes nice teamwork kind of thing as well. But if that was all it did, I admit, it would still be kind of hard for me to say sometimes. But let me show you something else we can do for it. First, let's make some new shirts. So shirt 1 equals a new shirt. Right, capitalization. Let's make this, see, got to remember here we provide the size, the color, and the type. Okay, so it's going to be a large. Let's make it a small. And color is going to be gray. And it's going to be a button-up. No teacher I know likes button-ups. Do you? Anyway, we'll make a new shirt. This one will be medium. And it will be hot pink, my favorite. And then we'll make it a long sleeve. Oh, you know, it'd be fun. Let's make a method that bleaches it. Yeah, that'll change the color too. You can see that you can change that public void bleach, and obviously color becomes white. Now I've bleached some stuff before. Some colors don't just turn white, but let's just assume it turns white. Okay, all right, and let's call it bleach white. Whee. Okay, all righty. Okay, so. Now, boy, gosh, I just want to, like, you know, I could do a lot of things here. I could drive those cars. I could make these kitty cats speak. I could bleach all my shirts. But, you know, I mean, that stuff you know already. I can do all those methods. But what if I wanted to, like, look at the colors of everything I have? Maybe I'm analyzing data to see if there's a certain color trend that I have, and thus I just want to look at the colors of these things. Well, you know they all have the same color, so you could say, you know, system.out.println, you know, mine.getColor, all right, and then you're like, okay, I just did my car, and then I'm going to do it again, and you're like, okay, now I'm going to do yours. I can already tell this is a perfect job for a loop. But how do I loop over them? They're not an array. I can't put them in an array because they're not all the same object type. I can't put them into an array list. They're not all the same object type. I wish they were one kind of object. I wish they were just like colorable objects. Wait, they are colorables. Every single one of these is colorable. Oh, so why don't I make an array list of colorables called my collection equals a new array list. Huh. Well, that's kind of nifty. It accepts colorable as a type because it is. It's an interface that describes certain objects that are guaranteed to have one method. What method was that again? The drive? No, cars only drive. Bleach? No, we only bleach shirts. I guess you could bleach a car. It's kind of weird, but anyway. They all get color. Yeah! So they all do actually share something in common. So why not? Why not be able to call them colorable objects? This right here is called polymorphism. It is freaking sweet, dude. Polymorphism is the idea that we could morph our objects into different types of objects and classes. and interfaces because they're more than just the sum of their parts. Just like you're a human, I could cast you to a male or a female. I could cast you to your age type. I could cast you to a student, a teacher, an adult, a young person, whatever. Think of all the different ways things could be classified. And that's polymorphism, okay? And the thing about polymorphism, that allows us to have some really cool abilities and store things in really, really neat ways. So now to my collection, I can just add any kind of colorable object. I'm going to add mine. And then I can copy that, do this a whole bunch of times. You might say, oh, wow, you have to do this anyway. This would have been hard. Well, to be technical, I could have just made this at the beginning and instead of just adding mine, yours, I could have just said add a new car, Ford Mustang Red 28.4, and it would have just made the object, because I don't really need those references of mine, yours, and all that stuff. But let's just add them in here. Okay, so those added all the cars. Let's see if it adds kitty cats in too. Cat 1. Ha! It allows cats in there too. That's right, because cats are colorable. And cat 3. Yeah, we definitely don't have a bleach method for them. Yeah, that'd be a problem. Let's also add in here shirt 1. Oh man, look at this. I can add in other things. This is so neat. Okay, and now I can just use a loop to loop over and print out all the colors of things we have. So for every, well, we'll use this as a base loop first, but I really hope if you're just printing something out, you're going to realize, hey, for every loop would be better here. Well, I is less than my collection dot size, I plus plus, system.out.println. We have to get it, so collection.get I dot get color. Bam! Look at that. It works. No problems. This is awesome. So let's do it. Let's run this sucker and see what happens. Ha! Huh. Red, orange, blue, spunky, Bessie Raptor. Ha! Huh. I think I made some mistakes on my objects there. Yeah, I think these are supposed to be colors first. Oops. Yeah. Yeah. Let's make this a name first and a color next. That'll fix my problem there. And we forgot to change the get color method of our shirts. We were still returning the empty string. So, there we go. Let's try this all one more time. There we go. Red, orange, blue, black, calico, white and black, purple. Purple cats are cool. And gray and hot pink. So that's awesome. Okay? Isn't that neat? You can polymorphize them to one type, a colorable type. Now, there's a problem. Not a problem, but here's just something you got to think about. I apologize for the bell. You'd think on a Sunday they wouldn't do that. What if you want to use some of the other methods? Okay? Well, the problem is when you polymorphize things, when you cast them a different kind of object or different type, then you lose kind of scope of methods that you shouldn't be able to get to anymore because they're not of that type. So technically, since these are all just considered to be colorables now, then the only thing we can really do is call the get color method. You can't call any other methods. But you're like, wait, I want to bleach the shirts. So why can't I take the collection dot get I dot bleach? Wait, what? It can't find it. Location, interface, colorable. Because bleach is not something that all colorables have. Only shirts have that. Okay? Like if you think about it right now, you'd be trying to bleach a car. There's no method for that. You'd be trying to bleach a cat. And if you try to bleach a cat, I got a phone number to call. Watch a little bit later. I'll put it at the bottom of the screen. Anyway, yeah, you can't bleach cats, but you can bleach shirts. But the problem is Java's not going to let you do this because it's like, well, you're telling me they're colorables, so they got to be colorables. Don't do that. So it does have some good and some bad things. That's not bad. That's technically good. Okay. There are ways to get out of this. So if you want to go backwards and take them and say, well, if it is a shirt, go ahead and bleach it before we get its color. There's a quick reserved word we can use to do that. You can actually do this thing called if collection dot get I. So if that colorable object is an instance of a shirt. So if it's a shirt, then collection.getI, we can get it. We're going to have to cast it. So we're going to have to cast this to a shirt type now because we now know it's a shirt type. So cast that to a shirt type and bleach it. And there you go. So if the collection.getI is an instance of a shirt, then change it to a shirt for now and bleach it. Okay? So that's the instance of, and that's a way to pull things back out of their more specific interface and more back to their more generalized object form. I guess you could call the object more specific than the interface. So that's a way you can do it. That's kind of helpful. Okay, so it's a way you could check to see if it's an instance of a certain object. Okay, so that's a way polymorphism can still be helpful. But either way, we'll go ahead and print out the color. Okay, so this time we should see bleach white shirts. Okay, see, bleach white shirts. Okay, so that's how we use interfaces. It's pretty neat. Okay, so this is a really nice introduction. I'm going to do another video here in a little bit on a concrete way we use these. So one way we're going to use them is using listeners in our graphics programs. And so I'll show you how to do listeners that do different things. Again, something that listens is going to, maybe it's something that just hears for, smoke signals. How do you hear for a smoke signal? Anyway, but listeners are another way we use interfaces. So we'll take a look at that in another video. I provided this whole project on the comments section of this video. So if you want to just download it and play with it yourself, feel free. Okay. If not, you guys have a good day, and I'll catch you next time. Have a good one. See ya.